This is video number 7 for the exam prep series for the half-yearly exam that's coming up. Looking at chapter 14. So chapter 14 is all about chemical reactions, and you need to know the main chemical reactions, which are acid-base, acid-metal, acid-carbonate, combustion, and decomposition. Now the first three, acid base, acid metal, acid carbonate, they all result in the formation of a salt, an ionic compound. So that's easy to know. Acid base, they neutralize, they cancel out their pH, and they give you a salt and water. Acid metal, when you chuck a metal in acid, like magnesium metal into hydrochloric acid, you get salt and bubbles, and those bubbles are hydrogen gas. Acid carbonate, if you chuck in chalk into hydrochloric acid, so chalk is calcium carbonate, you get salt, you get carbon dioxide gas, and you get water. Combustion involves a substance, could be anything, could be a metal, it could be a fuel like methane, plus oxygen gives you either carbon dioxide and water, or carbon soot plus water, or carbon monoxide plus water. So combustion, you've got two main types, if you recall. You've got complete and incomplete. Complete combustion means there's a plentiful supply of oxygen, so you get carbon dioxide. That's complete. Incomplete comes in two main forms. You've got the formation of soot, okay, which is carbon powder. It's a solid, black solid, plus water, or carbon monoxide and water. Okay, incomplete combustion is more dangerous than complete combustion. It's more harmful to the environment and to the human respiratory system. They can pollute the atmosphere and so on and so forth. Decomposition involves a substance, let's call it XY, decaying into its constituents, X and Y. And it's a result of the conservation of mass, which means that whatever you start at the beginning, you have to have at the end. So a substance made of X and Y can only break down into what it's made of, X and Y. Okay, it can't break down into gold, for example. So they're the main reactions. Just a note as well for combustion. Combustion is exothermic. You must know this. Exothermic means it releases energy, releases heat. Okay, but it involves burning. It's exothermic. Let's look at some examples. Okay, acid base, classic textbook example. So before I get into that, actually, common acids you need to know off by heart. Need to know these chemical formulas and names. HCl, this is hydrochloric acid. Hydro for H, chloric for Cl. Sulfuric acid, H2SO4. Sulfuric because it's got sulfur. Acid because it's got a hydrogen. And HNO3, this is nitric acid. Nitric because it's got the nitrate polyatomic ion, NO3. You need to know back here, water is H2O, chemical formula. Hydrogen is H2, it always exists as diatomic, two atoms stuck together. Carbon dioxide is CO2. Okay, and in combustion, oxygen is always O2 as well, it's diatomic. Just a note, chemical formulae. Let's do an acid base. Let's do hydrochloric acid. Plus sodium hydroxide. This is the most common acid base example in any textbook, even. Let's suppose they give you this in the exam. Most likely they will. Not the same reaction, but a similar reaction. You have to go from here to a balanced chemical equation. The very first step is to identify what type of reaction it is. When you see acid, obviously it's an acid. When you see hydroxide, that's a base. Okay, bases contain hydroxide or oxides. Okay, for example, you can have potassium oxide. Okay, that's a base. That's step number 1. Step number 2 is to write the products. So you get salt and water. Step 2 in blue. Step 3, let's write down the name of the salt. Salt is always a metal and non-metal. Now in the exam, it's preferable to do this on the side because you won't have enough space for working out typically. Metal goes first. Metal comes from the sodium. That's the only metal there is in the reactants. So sodium. The non-metal comes from the acid ending. The chloric becomes chloride. Okay, it doesn't make sense to say sodium chloric. In chemistry, it's sodium chloride. It's just the convention. That's step number 3. Step number 4 is to write down the chemical symbols. Now, hydrochloric acid, back to here, is HCl. Sodium hydroxide, Na, and OH. Now, Na is sodium. It's in group 1, right, +1, that's the valency. Hydroxide is -1. We need to write valencies because when you split a compound, which is neutral, into its constituents, you get ions. Okay, because ions, when they combine, they become neutral, right? Becomes salt, sodium chloride. Sodium is Na +1. Chloride is chloric Cl -1. Chlorine, it's in group 17, valency -1. Water is H2O. That's the hard bit. Easy bit is just put it together. NaOH, stick them together. The -1 and +1 cancel out. Makes NaCl. Similarly, the +1 and -1 cancel out. Plus H2O. So let's balance it now. Make a list from left to right, HCl. So we're making a list of the atoms here. Be very careful. HCl, NaO on the right as well. And you just count. There's 2 hydrogen on the left, 1 chlorine on the left, 1 sodium on the left, and 1 oxygen on the left. 2 hydrogen on the right, 1 chlorine on the right, 1 sodium on the right, and 1 oxygen on the right. So it's balanced. That's all balanced chemical equation for an acid-base reaction. I want you to try and do this. And write me the balanced chemical equation for that. I forgot to mention as well back up here, there's also corrosion. So let's put it as number 6. Corrosion is a form of combustion, but it's a slow form of combustion. Combustion you can light a match in a split second. Corrosion, so the rusting of an iron nail, let's say, can take days. Okay, it involves oxygen. It's an oxidation reaction. You must know this. So an oxidation reaction involves oxygen. Same with combustion.